So we're going to talk about elimination, another method to solve a system of equations. This method is easy when, sorry, I'm bad handwriting here. When variables can have opposite coefficients. That's kind of the key here you need to be thinking about. When variables can have opposite coefficients. And we can force that to happen by a variety of means. Okay, so step one is to make them both look pretty much in standard form. I'm going to put standard form in quotes because it doesn't necessarily need to be perfect standard form. Step two is to multiply both sides of the equation by constants to force one set of unknowns to have opposite coefficients. Step 3 is to add both sides, eliminating that variable. Step 4 is to solve, and we'll kind of leave that as the dot 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 here. So let's look at number 1, what I mean by this. Step 1 is x and y on both the same sides. Well, it's a and b, so that's already true. Step 2 is to multiply both sides by something that's going to make a variable become essentially the same thing. Well, if I look at this, my b's are already lined up to be opposites, so that's convenient, which means we're going to put a little bar here and add a plus a is 2a, b minus b is 0, and 5 plus 7 is 12. Look at what I have left. Well, if I divide both sides by 2, I get a is equal to 6. Now, how do we figure out what b is? Well, go ahead and substitute it back into one of these. If I substitute it into the second one, for example, I get 6 minus b is equal to 7. Subtract 6, and I have negative b is equal to 1. Multiply both sides by negative 1, and I have b is equal to negative 1. This gives me the order pair 6, negative 1. And I've got it. Let's look at number 2. They're almost the same, but you know, we get to decide. I don't really like these fractions too much. Is it going to be convenient for us to keep them? Well, if I look at these are almost the same thing. Let's change the signs on the second one by multiplying both the left and the right sides by a negative 1. So I'm going to have negative 1 here, negative 1 there, and if I rewrite it, 3/4 x minus 1/6 y is equal to negative 12. Negative 5/4 x plus 1/6 y is equal to positive 22. Now I can add because these are going to eliminate, and I have negative 5/4 plus 3/4 is negative 2/4 x equals 10. Well, negative 2/4 is negative 1/2 x, and if I multiply both sides by a negative 2, I get rid of the negative 1/2. And you get x is equal to negative 20. Now, we're going to want to substitute back into one of the original two. I'll pick the first one. So you have 3/4 times negative 20 minus 1/6 y is equal to negative 12. 3/4 of negative 20 is negative 15 minus 1/6 y is equal to negative 12. Add 15 to both sides. You have negative 1/6 y is equal to 3. Multiply both sides by a negative 6, and I get y is equal to negative 18. Okay, next one. I see that I don't have them lined up, so I have to pick a variable to target. Maybe I'll pick the y's, because if I multiply the numerator by a 2, then it's going to become 2y. So let's rewrite this. 2x plus 2y is equal to 14. And 3x minus 2y is equal to 11. Add, and you get 5x is equal to 25, or x is equal to 5. Substitute back, and I get 5 plus y is equal to 7, or y is equal to 2. So express it as an ordered pair. And we have 5, 2 as our solution. Number 4, if I multiply the top one by a 2, or I guess I could multiply the bottom one by a -3. Let's do that because it's a little different. Just to show that we have options. If I multiply the bottom one by a -3 on both sides, rewrite the top one, 18a minus 5b is equal to 17, and then the bottom one becomes negative 18a minus 30b is equal to positive 18. Add, and I have negative 35b is equal to 35, or b is equal to -1. Substitute it back into one of the original two. 18a minus 5 times -1 is equal to 17, or 18a plus 5 is equal to 17. 18a is equal to 12, or a is equal to 12 over 18, which simplifies to 2 over 3. Parentheses, 2 over 3, and -1. The rule is you put them in alphabetical order, always. So, let's move on to the next set. If I look at this, really, I say x and y on both sides. I don't really need the 10 and the 25 on the other side, but what I do need is to have either the z's or the t's cancel. If I want the z's to cancel, then I need to get the 6 and the 4 to match something. Maybe they'll match 12. So let's multiply the top one by a 2 and the bottom one by a -3, so that basically they form opposites. I'm going to rewrite it. 12z minus 10t plus 20 equals 0, and then -12z plus 21t minus 75 is equal to 0. And add. We get -11t, or positive 11t. This would be positive 11t minus 55 is equal to 0. Add the 55, and I get 11t equals 55. Or t is equal to 5. Now we plug it back into, I can see the second one, it's just visible, so 4z minus 7 times 5 plus 25 is equal to 0. Or 4z minus 35 plus 25 is minus 10 equals 0. 4z equals 10, and then I have z is equal to 10 over 4, which reduces to 5 over 2. Like I said, we'll put them in alphabetical order, the 5 first and the 5 halves second. Brace, brace, and circle. The next one, if I look at that second equation, it's not in a good form. Let's rewrite that as x over y is equal to -2 over 3 and do a cross product. If two fractions are equal, their cross products are equal. So I'm going to make this -2y is equal to 3x, and then we're going to move the let's move the 2y over to the other side, make it 3x plus 2y is equal to 0. Now let's look at this one and multiply it by an LCD. 24 should clear the fractions, so I would get 3x plus 4y is equal to 24. And if I move that and make it, multiply this by a negative, I have -3x minus 4y is equal to -24. And now I can add them and get rid of the x's. -2y is equal to -24, or y is equal to 12. If y is equal to 12, let's plug it back into one of the original two equations, maybe the first one. So x over 8 plus 12 over 6 is equal to 1, or x over 8 plus 2 is equal to 1, which is x over 8 is equal to -1. Multiply both sides by an 8, and I get x is equal to -8. So my order pair is -8, positive 12. Let's move on to number 7. I again don't like fractions, so if I multiply both sides by a 3, actually let's do it by -3 to make the y's cancel. So then I get -x minus 3y is equal to -27. Then I have x plus 3y is equal to 8. And if you add those, you get, okay, so that cancels, and adding makes it 0, equals -19. That is most decidedly not true, which is kind of a problem. So if that's not true, it's a no solution. And if you look at the original two, that meant that they were parallel lines, kind of like we had before. That's what no solution means. You can probably predict what number 8 is going to look like, but let's do it anyway. If I multiply the bottom one by a 3, and I rewrite the whole thing, I have 2x minus 3y is equal to 6, and then negative 2x plus 3y is equal to negative 6. And if I add these, I get 0 equals 0. And that is true, unlike this one, which was false. If it's true, we're going to go back up to the original equation and pull this down and say, well, now I want to write that in slope-intercept form. Negative 3y is equal to negative 2x plus 6, and y is equal to 2/3 x minus 2. And we're going to put that into the set notation by saying that the truth means that all the xy ordered pairs that satisfy this line of y is equal to 2x plus 6, or 2/3 x minus 2, sorry, y is equal to 2/3 x minus 2 are true. So your solution is what I'm writing right now in set notation, if I can draw the brace right. This you must memorize how to do. I'm going to highlight this because you need to refer back to this example to see how to do this, since that's new. This means all xy such that the line is true.